So welcome you all. Today we will see the transient thermal analysis of absorber plate, which is used for aerating. So start with the ANSYS workbench. So this window will open. Last time we have seen how to create absorber plate for liquid heating. Today we'll see how to create absorber plate for aerating system. So you have to go with the transient thermal analysis. We have engineering data, geometry, model, setup, solution and result. So one by one we are going to do this. First of all, going to the geometry, I am selecting ANSYS design modeler. So in design modeler we are preparing the geometry for the same. Click on any one of the plane so that this will be visualized. X, Y and Z. X, Y and Z. X is red, Y is green, Z is blue. Then you select the units. I am selecting centimeter. Now next thing, you have to create a primitive. So I want to create a plate, so that's why I am creating a primitive. First of all, make it add to frozen. Then select the suitable dimension what you are interested in. Say for example, this is my 50 centimeter. X component I want this is to be 25 centimeter. Y component I required at 0.25 centimeter. So very small thickness of the plate I am considering over here. You can just check it out in this case. Now I am going to make it generate over here. So first of all, I generated the plate. Now I am just going to create fins for this, as we are using it for aerating system. That's why we need to create fins for the same. So how to create the fins? You can create again box. So this is one box which you can see the wireframe model. I am just reducing the dimension so that you will be able to visualize this box over here. Okay, so now you can see the box is there. Now how you want your orientation? I want my orientation to be along y direction only. I don't want my object to be in we can say x direction. I just want my object to be in z direction. More specifically, according to that I am going to specify the dimension. So x component I am taking a low value, say for example 0.5. You can see here, you can take it smaller than this also, say 0.25 I have taken. Then vertical distance I will make it 1 centimeter, or you can take it somewhere around 2. So as to visualize the pin, I am taking 2. Then Z component you will take as per the length of your plate. So what was my length of plate? Length of plate my was 50. So I am considering this as a 50 centimeter over here. Now you can just check how this is the one pins which are being produced. I don't want this at this point. I want at some distance. So total distance is 25. So I will take some coordinate that is equal to 5 centimeter over here, or you can take somewhat less value 0.25, but I want this in negative direction of y. So you can specify negative direction value. Here we are taken 0.25 as a thickness, so I will specify this as minus okay, just check it out, -2 I have taken as the distance. Now I will make it generate. So before that you have to make it as to frozen, then you can generate this. So this is a fin which is been produced at other end. Now you want similar kind of fins on the entire length of your plate, or entire we can say this x direction. You want the many number of fins on this part. So what to be done? I am just going to create go for the pattern. So select the body if you are having, make it apply direction. Direction you need to select. So click on any one of the plane. Is this the direction which we require? No, just take it another direction. Just take one, this one, make it apply. So specify whatever the number of plates you want, say for example 3. Okay, so distance you have to change to 5. See here, You can see plates has been produced. I will try to prepare one more plate over here. So 4 numbers I will prepare. You can see there are 4 plates are been created. So in this way you can create fins for your we can say absorber plate. So in this way I have done this particular preparation of fin. Now I'm just going to do this as a unite part over here. So what is the purpose of providing the unite part? The purpose of providing a unite part is to just we say make this boundary condition applicable at single point. So first of all I'm going to generate with a single plate. Later on I'm going to generate with a double plate. So taking one more. Okay, so first of all going for boolean operation, select all the parts, make it apply, and then generate. Now this becomes a single part. Now this becomes a single part. Now you can apply your boundary condition and you can proceed. So first of all this is the geometry which has been created. Now I will proceed for the next part of this. So next part will be to prepare mesh and to prepare apply the boundary condition and later on to visualize the result. So all this comes under model. So depending on your system configuration it may take some time to start the model. Okay, so first of all, first important thing is to prepare the mesh for the same. Okay, so first thing is to prepare the mesh for this object. So I have by default mesh I have selected. You can select by default mesh also, or you can reduce the size of mesh also. So reducing the size of mesh may involve more time for solving your problem. So I'm just solving this as it is as a default mesh. I will apply temperature at the top side, make it apply over here. At the top side I have applied initial uh, initial temperature and final temperature that you have to specify. This is initial temperature, final temperature I am going to specify as 40 degrees Celsius, make it apply. Then you have to go to the time setting. In that case whatever suitable timing you are considering, say for example 60 seconds, so that you should specify. Then in solution whatever you want to visualize that you should specify. So this is how the things are done. I will just click on the solve button. I'll check whether it gives me a solution or not. Later on you can modify the mesh also, but you need to remember which version of ANSYS you are using. Say for example I am using ANSYS academic. In that case there are limitations with the node points, and according to that you can proceed with this particular analysis. So first of all I am just, if you don't want to see this mesh over here, what you can do is you can no wireframe option you can select. In that case entirely the object will be visible to you. Now click on this part over here. You can see some variation in the temperature which has been taking place. For better visualization you can take out as a more number of frames like 100. Check out how the temperatures have been taking place. So I have taken somewhere around 60 seconds, but for 60 seconds I get completely as a red zone. So I will specify change this value to somewhere around 30, and we'll just check what happens to my analysis. So one more time I'm going to take 30 as a second, and then I will check out how the solution which is coming out. What I done, I just reduced the time time over here. Earlier I had taken 60, now I have taken 30. We'll just check it out what happens with this simulation. You can see the red zones are coming over there. So what is the indication of this red zone? Red zone, it will indicate you that we say heat has been transferred from the absorber plate to the other end. Now what is important in case of the flat plate collector system which are specifically used for heating, in that case you want to heat the air which is flowing across the fins. So air will take out heat from the fin, and that will be further used for some other application. So this is one thing which we have discussed with respect to the temperature. Then we have discussed with only one plate which is on one side. in addition to that, if somebody wants to visualize the temperature, you can visualize this is 40, then 39, 39, 8, 38, like that. So in this way you can get the maximum minimum temperature also, you can get the temperature points also. So if somebody wants to modify the mesh, you can definitely go on modifying the mesh. I'll just specify some value here, 0.02 Uriel. I'll just check whether the quality of mesh is become coarse or whether the mesh becomes fine. I think no much change as far as the quality is concerned. I'll just prepare one more time. I will make it update. We'll just check whether any changes are, yeah, you can see now there are changes in the mesh which has happened over here. So I will just try to solve this, whether it is able to solve or not, because sometimes what may happen, it may give error regarding to the limitation of academic version. As we are using the academic version, sometimes it gives error regarding to the academic version that you cannot proceed. But here as of now it is not giving any kind of error to us, so we can easily go for this simulation. You can keep a respective view wherever you want, and accordingly you can save your result. How to save your result? You can go with the export file here, and this file will be saved in terms of the video or animation. So in this way you can do the analysis on this plate, what we are discussed. Now I will just slightly go and modify this geometry, and will show you how we can say double plates are there, how it can work out. So I'm closing this mechanical. Now I'm going to slightly modify the geometry, so that's why I'm going to reset everything, otherwise errors can be there while doing the analysis, and that's why I'm making it as a clear generated data, and then I'm going to proceed further in modifying the geometry, and later on I'm going to change few things. Like one more time I'm going to prepare a box. I have to go for the primitive box. Now where I want the box, I want the box at the downside. Again x component will be 25, z component will be 50 over here. This will be 0.25 over here. At what distance we want? We want at a distance of 2. We'll just check whether it comes at, okay, -2 I will specify here. Yeah, you can check out -2, it is coming exactly down. Then make it at frozen and make it generate. So in this way at bottom also it has been generated. So again the work will be to do the boolean operation. So make it boolean, select both of them, make it apply and make it generate. So in this way one body has been generated, and through this gaps the air will go on to flow. So in this way we have prepared the geometry. Now we'll just go to the next part, that is related to a model. So first of all I'm going to clear generate data, and then I'm going to open this. So depending on your system configuration it will take some time. So this is the geometry which has been prepared. So I will go on to prepare default mesh first. Okay, you can see the mesh which has been generated. You can further modify the way I had discussed earlier. So I am specifying temperature. What should be my temperature? Earlier, say for example I am specifying 40. You need to select the surface at which you are going to apply this temperature, make it apply and make it generate. Initial temperature as taken as the normal one, I am taking 30 seconds over here, or you can extend also, say for example 60 seconds. Now in solution whatever you want to visualize, specify that. So this is your temperature, make it solve. Once this has been solved you will get some result. Slightly take the view in such a way that entire things will be visible over here. Now we'll just if you don't want to see the wireframe model, you can eliminate that, then go on to click this. You can see how the temperature variations have been taking place. So temperature initially was higher here, then temperature is uniformly distributed. So this is one shape by which we can circulate air, and we can say get the higher temperature for heating the air. Additionally you can select the probes also. If at any position if you want to know the temperature, then in that case you can select the probe. This is 31, this is 40, so you can see some 9 degrees Celsius of temperature difference, and in this way the heat is being transferred. If you change the shape to somewhat circular, in that case again you will transfer more amount of heat. So in this way we can do the analysis on plate. I have shown you two examples. One, it is a single plate whereas the fin was connected, and we see I have shown two plates which are connected where the air will flow through this channel. Thank you.